Hello and welcome to today's chemistry lesson. I'm your usual chemistry teacher. My name is Mr. Philip Mamman. If you don't have difficulties understanding the concept of organic chemistry, I'll just do a little breakdown here, and I hope that you can follow me on my YouTube channel, Philip Mamman, and you'll be able to learn more from the lengthy video. Today I'll be looking at hydrocarbons. Hydrocarbons are organic compounds that contains carbon and hydrogen only. Again, hydrocarbons are compounds that contains carbon and hydrogen only. Now, hydrocarbon can be grouped into saturated hydrocarbons and unsaturated hydrocarbons. I'll explain that in a moment, but then you must know that there are homologous series that belongs to hydrocarbon, and they are the alkane, alkene, alkyne, and aromatic. Alkane, alkene, alkyne, and aromatic. Now these four homologous series are basically hydrocarbons. Now hydrocarbons can be grouped into saturated hydrocarbon, like I said earlier, and when you say saturated hydrocarbon, you're talking about hydrocarbons in which carbon have used up all its 4 valence electrons in bond formation with other elements. And that is why we see carbon is tetravalent. The valency of carbon means carbon has a valency of 4. And in a situation where carbon have used all these 4 electrons to form bond with other element in a hydrocarbon, is referred to as a saturated hydrocarbon. And saturated hydrocarbons are characterized by the presence of a single bond. An example of saturated hydrocarbon is the alkane. We'll see alkane shortly, but then let's look at unsaturated hydrocarbons. What do we mean by unsaturated hydrocarbons? When we say unsaturated hydrocarbons, we refer to hydrocarbons in which carbon has not used up all the 4 valence electrons in bond formation with other elements. In such cases, there are usually multiple bonds. Like I said, unsaturated hydrocarbon are hydrocarbons in which carbon have not used up all the 4 valence electrons in bond formation with other elements. Now, these unsaturated hydrocarbons can be characterized by the presence of multiple bond. When we say multiple bond, we're talking about double bond or triple bond. When they have a double bond, we call them alkenes. It ends with E-N-E, alkenes. A-L-K-E-N-E. When they have triple bonds, we call them alkynes. A-L-K-Y-N-E. So double bonds are alkenes and triple bonds are alkynes. Remember that the triple bonded alkynes are more alkynes. Now, having seen saturated and unsaturated hydrocarbons, we'll be talking about aliphatic and alicyclic hydrocarbons. Aliphatic and alicyclic hydrocarbon. When you say aliphatic hydrocarbon, you're talking about an open chain hydrocarbon where you have your structure in an open chain. Okay, but when you say alicyclic, you're talking about a ring closure, a hydrocarbon where it is in a ring form. So they are called aliphatic hydrocarbon. Now, both aliphatic and alicyclic hydrocarbon can be both straight and branch. They can be straight and branch in both cases. Now, can we quickly look at alkanes? When we say alkanes, we're talking about saturated hydrocarbons that have the general molecular formula of CnH2n plus 2. That is the formula that you can use to write the structure or molecular formula of every member of the alkane family. The formula again is CnH2n plus 2, such that if n is equal to 1, it becomes methane. If n is equal to 2, it is ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. As you can see, they all end with A-N-E. That shows that they belong to the family of alkanes. Now, alkanes can be prepared in the laboratory, let's say a named alkane like methane, by the action of sodium ethanoate and soda lime. What is soda lime? Soda lime is sodium hydroxide mixed with quicklime. And what's the difference between sodium hydroxide and soda lime? The difference is that sodium hydroxide is the liquescent, meaning that it can absorb moisture and turn into solution, while soda lime is not the liquescent. And that's why soda lime is preferable to sodium hydroxide in the preparation of alkanes. Now, alkanes undergo what we call substitution reaction. And what is substitution reaction? It means replacing the hydrogen in an alkane with another element, such as halogens like chlorines. Now, when something is saturated, like I said earlier on, in the case of carbon, it has used up all its 4 valence electrons in bond formation with other elements. I want you to imagine a football team that have 11 players on the pitch. Can you add a new player onto it? The answer is no. By FIFA rule, you cannot add another player. What you can only do is to remove a player and replace him with another, and that is what we call substitution. The same thing in alkane, they can only undergo substitution reaction. On the other hand, alkenes are unsaturated hydrocarbons that are characterized by the presence of a double bond. This double bond shows that they are unsaturated, and because of this unsaturation, they can undergo what we call addition reaction. They can undergo what we call addition reaction. When you add hydrogen, we call it hydrogenation or addition of hydrogen. When you add halogens, we say halogenation or additions of halogens. Remember, your halogens are chlorine, bromine, iodine, and fluorine, just to mention but a few. Now, alkenes can be prepared in the laboratory by the dehydration of primary alkanols. By the dehydration of what? Primary alkanols. Your primary alkanols include your ethanol, for instance. If you remove water from ethanol, that's dehydration. And a very common dehydrating agent in chemistry is tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid. Remember, alkenes are unsaturated and they can undergo addition reaction. What about alkynes? Alkynes are also unsaturated. Remember that the degree of unsaturation is much more than that of alkenes, and that's why they have a general molecular formula of CnH2n minus 2. In the case of alkenes, they have a formula of CnH2n, and the corresponding name, since they don't have a first member. In the case of alkene, we say we have ethene, propene, and so on and so forth. What in the case of alkyne, we say we have ethyne, propyne, and so on and so forth. If you want to know more about IUPAC nomenclature, I would like you to visit my YouTube channel, where you will see comprehensive lessons on each of these homologous series, and you'll be glad you did. Remember, my name is Mr. Philip Mamman, and you can always check on YouTube Philip Mamman, and you'll see a series of videos, and you can watch them one after the other, and I'm sure you'll be glad that you did. Aromatic hydrocarbons talk about compounds of benzene. Alright, benzene has a simple formula of C6H6. Benzene can be prepared in the laboratory by the polymerization of ethyne. And how can you prepare ethyne in the laboratory? Ethyne can be prepared in the laboratory by the action of water on calcium carbide. Yes, if we see these welders that do panel beating, what they use is ethyne gas for welding. That's one of the uses of ethyne gas. Ethyne gas can also be used for artificial ripening of fruits. And if you buy fruits in the market and you see them with patches, you know that they were wrapping artificially, black patches. My wonderful students, I wish I can go on, but just take this as a tip of the iceberg. Join me on my YouTube channel, and I'm sure you'll be glad you did. Have a nice day.